Have you ever seen a rainbow after a storm? It's a breathtaking sight, a moment of pure magic that promises better days ahead. In this video, we will explore the science behind rainbow. This vibrant arc of colors is a symbol of hope and renewal, a reminder that beauty can emerge even after the darkest times. Rainbows have fascinated people for centuries, seen as bridges to the divine or symbols of promises kept. They inspire hope and wonder, bringing joy to both children and adults and reminding us of life's simple pleasures. But what makes a rainbow? It's the interplay of light and water. Sunlight refracts through raindrops, splitting into colors to create the spectrum we see. Rainbows are optical illusions, unique to each observer based on light angles and raindrop positions. The angle of light refraction and reflection inside droplets determines the rainbow's colors and shape. Understanding the science behind rainbows enhances their magic, adding appreciation for nature's wonders. Rainbows remind us that after the darkest storms, beauty can always be found. They symbolize resilience and hope. Next time you see a rainbow, appreciate the science and the promise of better days it represents. To understand rainbows, we must first understand light. Light is a form of energy that travels in waves. These waves travel incredibly fast, much faster than anything else we know of. Sunlight looks white, but it is actually a mixture of different colors. Each color of light has a different wavelength. Red light has the longest wavelength, and violet light has the shortest. When light passes through a prism, the different wavelengths of light are bent or refracted by different amounts. This separation of colors is called dispersion. It's the key to understanding how rainbows form. Rainbows form when sunlight interacts with water droplets in the air. These droplets can be from rain, mist, or even fog. When sunlight enters a water droplet, it slows down and bends. This bending of light is called refraction. The different colors of light are refracted at slightly different angles. This is because they have different wavelengths. After being refracted inside the droplet, the light reflects off the back surface of the droplet. This reflection is like a mirror reflecting light. The light then exits the droplet, being refracted once again as it passes back into the air. As the light exits the water droplet, it spreads out into its different colors. This is because the different colors of light were refracted at slightly different angles. The colors of the rainbow always appear in the same order: red, orange, yellow, green, blue, indigo, and violet. This is the order of the colors in the visible light spectrum from longest wavelength to shortest. The separation of colors in a rainbow is a beautiful example of the phenomenon of dispersion. It is the same phenomenon that causes a prism to separate white light into its component colors. A rainbow signature, the color arc. We see a rainbow as an arc because of the way refracted light reaches our eyes. Sunlight encounters raindrops, undergoing refraction, reflection, and dispersion, creating the spectrum of colors. The shape of a raindrop causes light to be reflected back in a cone shape. This process forms the cone of light we perceive as a rainbow. Our eyes see the light reflected at a specific angle, about 42 degrees from the direction of the sunlight, forming a circular arc. This angle is the optimal path that light takes through the raindrop to emerge and reach our eyes. This is why we see rainbows as arcs, with red on the outside and violet on the inside. The size of the rainbow depends on the height of the sun. When the sun is lower, the angle is more favorable for a larger arc. The interplay between sunlight and raindrops creates a mesmerizing display that has fascinated humans for centuries. Beyond the bow double rainbows and halos. Sometimes we see more than one rainbow in the sky. This phenomenon, known as a double rainbow, is a breathtaking sight that captivates anyone lucky enough to witness it. The vibrant arcs of color seem to paint the sky with a magical brush, creating a sense of wonder and awe. A double rainbow occurs when sunlight is reflected twice inside a raindrop. This double reflection causes the light to split into its constituent colors, forming two distinct arcs. The process is a fascinating interplay of light and water, demonstrating the intricate dance of nature's elements. The second rainbow appears above the primary rainbow and has its colors reversed. This reversal happens because the light undergoes an additional reflection inside the raindrop, altering the order of the colors. The primary rainbow displays the colors in the familiar order of red, orange, yellow, green, blue, indigo, and violet, while the secondary rainbow shows them in reverse. Halos are another optical phenomenon that can occur alongside rainbows. These luminous rings can encircle the sun or moon, adding an ethereal quality to the sky. Halos are often seen in colder climates where ice crystals are more prevalent in the atmosphere. Halos are bright rings of light that appear around the sun or moon. They are typically white but can sometimes display a spectrum of colors similar to rainbows. The appearance of a halo can signal changes in the weather, often indicating that a storm is approaching. They are caused by the refraction of light through ice crystals in the atmosphere. These ice crystals act like tiny prisms, bending and scattering the light to create the halo effect. The specific shape and orientation of the ice crystals determine the size and intensity of the halo. These additional optical effects add to the beauty and intrigue of the atmosphere. Rainbows and halos are just two examples of how light interacts with different elements in the sky, creating stunning visual displays that can inspire and uplift us. They remind us of the complex and fascinating ways that light interacts with the world around us. From the simple beauty of a single rainbow to the intricate patterns of a halo, these phenomena showcase the incredible diversity and wonder of our natural world. Each time we look up at the sky and see these optical marvels, we are reminded of the intricate and beautiful dance of light and nature. Rainbow in your garden. You don't need to wait for a rainstorm to see a rainbow. You can create your own rainbow at home with just a few simple materials. All you need is a garden hose, a sunny day, and a little bit of patience. Stand with your back to the sun and spray a fine mist of water from the hose. You should see a rainbow appear in the mist. You can experiment with different angles and water pressures to see how they affect the size and shape of your rainbow. The science of awe. Rainbows are a beautiful reminder of the power and wonder of science. They show us that even the most complex phenomena can be explained by the laws of physics. The next time you see a rainbow, take a moment to appreciate the science that makes this natural wonder possible. Think about the journey of light, the dance of refraction and reflection, and the magic of dispersion. Rainbows remind us that there is always more to learn and discover about the world around us. Conclusion: chasing rainbows. Rainbows, a spectacle of nature, are a testament to the magic of light. They are formed by a fascinating interplay of physics and optics. Sunlight, refracting and reflecting through water droplets, creates a spectrum of colors that arc across the sky. Understanding the science behind rainbows enhances our appreciation for these fleeting masterpieces. So the next time you're lucky enough to witness a rainbow, remember the intricate dance of light that created that breathtaking arc of color. Thanks for watching. Please subscribe and I will see you in the next video. Keep exploring.